Well, researchers at Oklahoma State University have gained nationwide attention for their efforts to design UASs to help study everything from tornadoes to a rancher's herd. Earlier, I sat down with Jamey Jacob, a professor of mechanical and aerospace engineering, who has worked on projects ranging from solar aircraft to a UAS mission on Mars. Well, Jamey, I cannot remember a time when UAVs have been in the news as much as they have been just in the past 6, 7, 8 weeks.
It really is an exciting time right now, and primarily, what's gotten all the buzz is that the long-awaited rules have been released by the FAA. Now, these are still proposed rules, but we've been waiting these for several years. So the fact that we finally have something to look at that gives us an idea what the future is going to look like, it allows us to plan now.
Clear up something for me, if you would. We call these, you can see it in our graphic here, the UAVs, unmanned aerial vehicles. But then in interviewing people for this show, a lot of them referred to them as UAS. What is the difference?
Well, the real difference is when we say UAV, we refer to that as unmanned aerial vehicle. In the moniker, the acronym has changed a little bit to really emphasize the fact that there's a system involved, and that's where the S comes from, unmanned aircraft system. And that's particularly important from the FAA's view. So if you're certifying a manned aircraft, what you're really worried about is just the aircraft. With a unmanned aircraft, what you now have to worry about is the control station on the ground as well. So we talk about a UAS, we're really referring to the entire system, not just the UAV. But if you refer to UAV, UAS, drone, they all kind of mean the same thing in modern parlance.
And I know there has been some concern about interference with the UAVs with aircraft, manned aircraft. Is there any way that these two can talk to each other?
Well, certainly, and if you look at the long-term plan for the FAA, they're requiring by 2020 that all aircraft, both manned and unmanned, will have ADS-B on board, and that's essentially a broadcast system that tells other operators in the area where your aircraft is, and that's going to include all general aviation aircraft. So if you're operating the airspace, you'll be able to know where all the other aircraft are currently at. Currently, right now, we don't have that capability, so there's not a process in place that allows air traffic control to see all aircraft in the airspace. And that's really the big issue with allowing unmanned aircraft to operate in the national airspace, is providing them with some capability that once that aircraft is in the air, it can see and then avoid manned aircraft. And that's really there to provide, safety for, both manned and unmanned aircraft, as well as people on the ground.
Certainly a hot technology. What are some of the areas that you're the most excited about?
But, it's a really exciting time, and I like to use the analogy of the smartphone. 10 years ago, nobody knew that they needed to have a smartphone, and they didn't realize all the things that could be done with it. And after this technology was put in the hands of developers, they came up with so many new things that they can do. And I think we'll see the same thing, once these rules are finally put into place. But some of the things that we're currently working on that we're excited about, is using these for first responders, having the capability, of every fire truck having a unmanned aircraft as part of its toolkit. So they can, get a bird's eye view of what that fire looks like, where right now they really don't have that capability. Weather monitoring, and of course you'll have lots of applications on the commercial sector, oil and gas, infrastructure inspection such as bridges and roads, and of course the biggest one is going to be precision agriculture. And if you look at what this means for Oklahoma, Oklahoma, our three most important economies are oil and gas, agriculture, and aerospace. And unmanned aircraft will be able to touch all three of those.
And you talked about these unmanned aircraft actually are being piloted by people, which means a workforce need, and that's something that you're working on and other people are working on.
There are a couple programs now across the state that are just getting started to be able to train unmanned aircraft pilots or operators. So there's a program here at OSU in aviation education that they're currently developing that will train unmanned aircraft pilots, as well as the Spartan Academy in Tulsa.
And I guess it's also important to get young people interested in this field, and that's something you do with what's become an annual event called Speedfest.
Yeah, so this is something that Professor Andy Arena started several years ago, and he's been working on this for many years. He originally started using unmanned aircraft as a teaching tool for our undergraduate students back in the 1990s. Designing an unmanned aircraft is just much like designing a manned aircraft. You can build it, test it, and fly it. And through this program that he developed, essentially became one of the preeminent undergraduate design, build, fly programs in the country. In this annual event that they used to participate in, they won more trophies at this than all other universities combined.
Yeah, and I think probably like any STEM field, it's always important to get people involved in it younger and younger ages.
Right. It gets them really excited. It's a hands-on activity. And the great thing about unmanned aircraft is, when you talk to young people about it, what you're doing is you're bringing all these different things together. You're bringing in aircraft and robots. And when you bring those two exciting things together and marry them now with computers, we do a lot of simulation, a lot of computer programming involved. It gets these young kids really excited about the technology and where it's going. And I think that's kind of the most exciting thing for the future, is they'll bring a lot of really new ideas to this. And we're only just kind of touching the tip of the iceberg in terms of what these things will be able to do.
So what about some of the practical uses that these could be applied to right now?
Well, some of the things that we're looking at, developing the technology for is to, for example, help first responders. Take the case of a wildfire. Of course, we've had a lot of really nasty wildfires here in Oklahoma the last several years. When a firefighting team comes up to a wildfire, they're essentially heading for the smoke. They have no idea the extent of that actual fire. And particularly if they're out of the metropolitan area, they have no aerial assets available, so they can't see what that fire actually looks like. We're developing the systems that will allow them to carry this essentially in the back of their fire truck. Once they get to the fire, be able to deploy this, get an aerial view of the fire, but also track first responders in the field. We had 19 firefighters lose their life in Arizona just a few years back, and that was all about situational awareness. They weren't able to communicate with other first responders on the ground, and they were not able to see the fire and the danger around them. So having this capability, we know will be able to save lives in the future.
And agriculture uses it a lot too, to monitor fields.
Right. We expect about 80% of the number of UAVs to be used in precision agriculture. Eventually every farmer will be able to have one, flying at relatively low altitudes and using what's called multispectral imaging, where you're combining both visible and infrared light together to be able to determine the crop health. And really what that's going to allow farmers to do is to apply nutrients, fertilizer, water to very specific parts of the field, and eventually save them money, so it's better for their bottom line, but it's also better for the environment.
All right. Jamey Jacobs, thank you so much.
Thank you.